Today's lesson is on dividing exponents. As usual, there is a video guide to go along with the lesson. If you haven't printed the video guide, go ahead and pause the video, print the video guide, and then come back. That way you can do the examples with me. So today we're talking about dividing exponents. We've already gone over multiplying exponents and how the exponents actually work differently from regular numbers. The front numbers we would multiply like normal, and then the exponents we would add. So today we're going to talk about division and how that works with exponents. So the first problem that we have on our video guide is x to the 8th over x to the 3rd. And I'm asking you to expand the problem. And remember what that means is just make the problem longer, actually write the whole thing out. Alright, so if I have x to the 8th power, expanding it means I need to show that this means to multiply x by itself 8 times. So I'm going to actually write this as 1, 2, 3, 4, 5, 6, 7, 8 x's being multiplied together. Okay, so that would be the top. For the denominator, the bottom, we have x to the 3rd. All right, which means we're multiplying x by itself 3 times. So I'm going to have x times x times x. 3 x's that are being multiplied together. Okay. Now, just one thing I want to point out, whenever they're doing division in these problems, they're going to write them as a fraction. Remember, a fraction is another way of writing a division problem, and we did that when we solved equations in previous lessons. Okay, so it's the same type of idea. Fraction means divide. So, when we're working with fractions, if we have something at the top and something at the bottom, those actually cancel out, okay? So having an x at the top and an x at the bottom cancels those out, and they're gone. Here I have another x on top, an x on the bottom, so those cancel out as well. And here's an x on top and an x on the bottom, so those cancel as well. I don't have any more x's in my denominator, so I can't cancel anything there. So now I just look at the top. I'm going to count how many x's I have left. 1, 2, 3, 4, 5. So x to the 5th power would be my answer. Now you can do this every time and try to cancel things out. However, that's going to take a while. And so we want to look for a shortcut. So I want to look for a way to get from the problem to the answer and skip that middle portion where I'm actually expanding the problem. Okay? So if I look, I have x to the 8th, y to the 3rd, and my answer becomes x to the 5th. Okay? Well, adding these two, 8 plus 3 gives me 11. Division does not work the same as multiplication. Okay? So this does not become x to the 11th. I don't add them together like I did with multiplication, which would make sense because dividing and multiplying are opposites. So if we think about it, it would make sense for us to do the opposite of what multiplication is. Well, if multiplication is adding the exponents, then division is probably subtracting. So let's take a look. If I subtract my exponents, 8 minus 3, 8 minus 3 is 5. And that is our rule for dividing exponents. So that's the rule that we want to write down. Okay, so whenever we're dividing exponents, we actually subtract the exponents. Now, the front numbers will stay the same, and we'll go over some examples with that, okay? It's still a division problem, so just like for multiplication, the numbers out front, the coefficients, we multiplied just like normal, but we added the exponents. That's how it's going to work for division. We'll divide the front numbers, and then we'll subtract the exponents, okay? So we'll go ahead and take a look at a couple examples together now. For problem number 3, we have vu to the 6th over 6u to the 3rd v to the negative 6th. The first thing we want to do for these problems is look at the numbers out front, just like we did for multiplication. So if I take a look, there's actually no number out front at the top, so I'm going to go ahead and put a 1 here. Remember, there's always a number in front of variables. They just don't always write it, okay? So if it's a 1, or if it's not written, it is a 1. So I'm going to take a look at this. I have 1 over 6. Now the first thing I want to check is, can I divide those two numbers? 1 divided by 6. Well, 6 does not go into 1, so I cannot divide those. The next thing you want to check is, can I simplify 1 over 6, the fraction, okay? Work with this like it's a fraction. 1/6. The only thing that 1 is divisible by is 1, and dividing 6 by 1 is 6, so it won't change the fraction. So we're going to leave our fraction as 1/6. It doesn't divide, it doesn't simplify, leave it the way it is, okay? After that, we're going to subtract the exponents. Now, we always subtract exponents top to bottom, okay? So I'm going to start with the V's because that's the first letter I come to. Doesn't matter which one you start with, but I'm going to start with V. Now this V does not have an exponent. Whenever there's an exponent missing, remember it's a 1, they just didn't write it. So I'm going to go ahead and put a 1 here. So for my V's, and I like to label which letter I'm working with so I remember which one I'm doing. For the V's, I'm going to take the top number, 1, and subtract from it the bottom number. Okay, make sure you're working with V. This is V to the -6, so I'm going to subtract -6. You need the subtraction sign, you need the negative sign because it will change your answer, okay? So I want 1 minus -6. Now remember, for subtracting integers, you change it to adding the opposite. So instead of 1 minus -6, I'm going to make it 1 plus +6. Add the opposite. Okay, so 1 plus 6 is 7. So this is going to be V to the 7th power. Now, that is a +7, so that means V belongs at the top of my fraction. I already have a fraction written, so we might as well put it where it belongs. So +7 means it goes at the top as V to the 7th. After that, we need to look at the U's. For U, at the top we have a 6, so it's U to the 6th, and we're going to subtract from that, because it's division, the bottom, U to the 3rd, so 6 minus 3. We can change that if we want to, but 6 minus 3, most of us can go ahead and do. 6 minus 3 is just +3. So that means my exponent for U is a +3, which means it goes at the top of my fraction as U to the 3rd. Now, one last thing I want to point out. This is the correct answer, however, 1 times V to the 7th is just V to the 7th. So they will write the answer as V to the 7th, U to the 3rd, all over 6. They will not put the 1 in front. So this would be our solution for number 3. Let's go ahead and take a look at problem number 4. We have 2U over 6U to the 4th, V to the 4th, okay? First thing I want to do is go ahead and take a look at that fraction, 2 over 6. 2 divided by 6 is the first thing I want to try, because if I can divide them, I want to. That's just going to make it easier. But 6 does not go into 2, so I cannot divide. But looking at this as a fraction, 2/6, I can simplify. So to simplify this, I have to think 2 and 6. 2 and 6 are both divisible by 2. So I'm going to divide both of these numbers by 2. So 2 divided by 2 gives me 1 at the top. 6 divided by 2 gives me 3 at the bottom. So 1/3. 2/6 simplifies to 1/3. Then I can go ahead and work with my exponents, right? So we're going to start with U, because that's the first one I come to. This U does not have an exponent. Remember, that means there's a 1, they just don't write it in. So I'm going to go ahead and write it so I don't forget. So for my U's, we're always going to do top minus the bottom. So I'm going to do 1 minus 4. So 1 minus 4. I'm going to change this to adding the opposite. Remember, your first number always stays the same. The subtraction sign becomes addition. And we want to do the opposite of +4, which is -4. So I have 1 plus -4. Well, my signs are different, which means we will subtract. 4 minus 1 is 3. Keep the sign of the bigger number. So this is U to the -3rd. Well, if it has a negative exponent, that means it belongs in the denominator of my fraction. And I'm going to go ahead and put it there. So U goes at the bottom, Once we put it at the bottom, we give it a positive exponent, u to the third, okay? So that's where it belongs. Now for my v. I have v to the fourth at the bottom. I have a lot of people look at that and say, oh, that means v just belongs at the top. Put v to the fourth at the top and you're done. Please don't do that, okay? Subtraction is kind of tricky, especially when you're missing a letter. Addition and subtraction work differently when you're missing something. When we had numbers missing before, we could have put in 0, but 0 plus 3 is the same thing as 3, and 3 plus 0 is the same thing as 3. See, they come out to be the same, okay? So for adding, it really doesn't matter where the 0 is. It's still going to give you the same number. Subtraction works differently. If I have 3 minus 0, I get 3, just like up here. But if I have 0 minus 3, I actually change that to adding the opposite, 0 plus negative 3, and I get negative 3. These are not the same, right? One's a positive 3, one's a negative 3. So subtraction works differently. Because of that, I want you to actually work out the subtraction, only because it can get kind of confusing as to where the letter actually belongs. But if you do the subtraction with a 0, you'll know exactly where it should go, okay? So I want to actually work out the subtraction for v. Now v is missing at the top. There are 0 v's at the top of my fraction. If there are 0 of that letter, that's the exponent. So we have v to the 0 power because it's not there. It is missing, okay? There are 0 of them in the numerator. So that's what I'm going to subtract. I'm going to do v, and then we'll do 0 minus 4. Okay? So 0 minus 4, top minus the bottom. Well, I change that to adding the opposite, 0 plus negative 4. And 0 plus negative 4 is negative 4. So v belongs in the denominator. I did not need to move it. So I'm going to put v to the 4th power in the denominator. And this would be my answer. I don't want to take that 1 away because there's nothing else at the top. So my answer is 1 over 3u to the 3rd, v to the 4th for number 4. For problem number 5, we have 5x to the negative 2, y to the 6th over 5x to the negative 2, y to the 2nd. So remember, this is a division problem. So the first thing that we want to do is look at our front numbers and figure out if we can divide them. If we can't divide them, we'll simplify them like a fraction, and if we can't simplify the fraction, we keep it the same. So looking at my two front numbers, 5 divided by 5, I can obviously divide those two, so that's going to make it a lot easier. 5 divided by 5 is just 1, so I'm going to go ahead and put 1 for my division part. After that, we need to actually work with the exponents. Now remember, for dividing exponents, we actually subtract. So I'm going to start with x because that's the first letter that we come to. So I have x, and it's always the top minus the bottom. So I'm going to start with negative 2, and then I need my subtraction sign. And then the bottom exponent is negative 2 as well. So I need minus and negative 2. Remember, you need the subtraction sign and the negative sign if it's there. Well, when we're subtracting integers, we know that we need to change those to adding the opposite. So my front number stays the same, negative 2, but adding the opposite, subtraction becomes addition, and instead of negative 2, I'm going to make it a positive 2. So positive 2. Well, negative 2 plus 2, the signs are different. We subtract them. 2 minus 2 is 0. And we talked about before when we were doing multiplication of exponents. If you get a letter with an exponent of 0, that means there are 0 of that letter in the problem. So you don't write that letter anymore. So x actually cancels itself out. It's gone. Now we can look at y. For y, we have y to the 6th over y to the 2nd. We need to subtract the exponents. So we're going to start top minus the bottom. So we're going to have 6 minus 2. Well, 6 minus 2 I don't really need to change because I know what 6 minus 2 is. That's 4. And it's a positive 4, So that goes at the top of my fraction. So y to the 4th. I don't have any negative exponents, so 1y to the 4th is the correct answer. But remember, they will simplify this a little bit further. 1 times y to the 4th is the same thing as just y to the 4th power. So this is how they would write the answer for problem number 5. For problem number 6, we have b to the 3rd over 5ab to the negative 4th. The first thing that we need to do is look at those front numbers, okay? Well, I have a 5 at the bottom, but there's no number at the top. Remember, there is a 1 there, they just don't write it. Anytime you have a letter all by itself, there's a coefficient of 1. So I'm going to go ahead and put that 1 in. So I have 1 over 5, 1/5, okay? Well, 1 is not divisible by 5. And if I look at the fraction 1/5, I can't simplify 1/5, so I'm going to keep that exactly the same, 1 over 5. No simplifying needed. From there, I'm going to go ahead and take a look at the b's, because that's the first one I come to. B to the 3rd over, make sure you look at b at the bottom, b to the negative 4th. We're going to subtract the exponents because this is a division problem. So for b, we're going to take top minus the bottom. So we start with 3 minus negative 4. Again, you need the subtraction sign and the negative sign. Once we have this written, we're going to go ahead and change this to adding the opposite. So my 3 stays the same. My subtraction becomes addition. And my negative 4 becomes a positive 4. Add the opposite. So 3 plus 4 is positive 7. Which means b has an exponent, a positive exponent of 7. So it goes at the top of my fraction as b to the 7th. Now, we talked about when letters are missing in a previous problem, problem number 4. We have an a in the denominator, but we're missing a in our numerator. Remember, you can always put the letter in with an exponent of 0. Because a is not at the top, that means there are 0 a's there. So we'll put a to the 0 power. That way we can actually do our subtraction and figure out where a belongs. Now this a at the bottom, it is written there, it just doesn't have the exponent. So the exponent that we write is a 1, because there's one a at the bottom, so you'll give it a to the 1st power. And now we can actually subtract them. So for the a's, we're going to do top minus the bottom, so that's 0 minus 1. We can change it to adding the opposite. Your front number stays the same. Subtraction becomes addition, and instead of a positive 1, I will make it negative 1. So 0 plus negative 1 is negative 1. Well, if we have a to the negative 1, that means it goes in the denominator of our fraction, so I'm going to put it by the 5 as a to the 1st power. Now, this is technically the correct answer, but remember, they won't put those 1s there. 1 times b to the 7th is the same thing as b to the 7th. Over, we have 5. Now, a to the 1st is the same thing as just writing a. So I can write this as just 5a. This is how they will write their answer. This way is not incorrect, but it's not simplified all the way. And they won't write it that way because they want it simplified all the way down to where there's no 1s involved, okay? So this is how we need to write our answer. b to the 7th over 5a. At this point, go ahead and pause the video, try to do numbers 7 and 8 on your own, and then come back to the video and check your answers with mine. For problem number 7, we had 2u to the 3rd, v to the 5th, over 6u to the negative 5th, v to the 2nd. The first thing I did was look at my two front numbers, 2 and 6. I noticed that 2 is not divisible by 6, but I can simplify the fraction 2/6. They're both divisible by 2, so 2 divided by 2 gave me 1, and 6 divided by 2 gave me 3. After that, I subtracted the exponents. So always subtract from top to bottom. So I took 3 minus negative 5, and I changed that to adding the opposite. Remember, I changed those integers. So we have 3 plus positive 5. Well, 3 plus 5 is 8, which means u belongs in the numerator of our fraction, u to the 8th. From there, I went and looked at the v's. for the v's we did 5 minus 2, top minus the bottom. So 5 minus 2 gave me 3, a positive 3. So that means it also belongs at the top of the fraction. Now I notice that there's a 1 at the top, and 1 times u to the 8th is just u to the 8th, and they will take off the 1. So I wrote my answer as u to the 8th, v to the 3rd, over 3. So that's problem number 7. And then for problem number 8, again, starting with those front numbers, 4 over 3. I can't divide 4 by 3, not without getting a decimal, so I don't want to do that. I can't simplify 4 and 3. There's no common divisor between 4 and 3. Also, I did not make this into a mixed number. I do want to point that out. 4 over 3, I did not change that into 1 and 1/3. They don't want you to do that, okay? So no whole numbers out front by themselves in these problems. They will leave them as improper fractions. So you leave it as an improper fraction. That's fine. After that, I went ahead and subtracted my exponents. I started with the y because that's the one that I came to first. So I did -3 minus -5, top minus the bottom. And make sure you go y to y, not y to x, okay? So -3 minus -5, I changed that to adding the opposite. So I have -3 plus +5. The signs were different, so I subtract them, and I keep the sign of the bigger number. So that gave me +2. Positive exponent means numerator of the fraction, so y to the 2nd went to the top. After that, I noticed that I was missing x at the top of my fraction. X to the 0 is what I put in its place. Remember, if any letter is missing, go ahead and put it to the 0 power. Doesn't matter if it's at the top or the bottom, okay? If it's missing, put that letter to the 0 power. So I have x to the 0, and I had to subtract my exponents. So 0 minus -3 is what I had over here. And I changed it to adding the opposite. So instead of subtraction, I made it addition. And instead of -3, I made it +3. So 0 plus 3 is 3. +3 for an exponent means x actually belongs at the top of our fraction, which is again why I want you to write these out. Don't just try to guess and say, oh, well, it's negative, so I'll just leave it down there. That's not how it works, okay? So do the subtraction. It shows us that x actually belongs at the top as x to the 3rd. So our answer is 4y to the 2nd, x to the 3rd, over 3. And that's the end of our lesson on dividing exponents.